latch. Okay. In the final lecture which I want to deliver in this particular series on the process of engineering design, I want to take up two specific issues. One is on risk management, other is on quality engineering. I want you to understand that both these topics are heavy in themselves, which deserve the treatment which will last for an entire semester, and I will in no way do justice to these topics by treating them in a very dilute manner here. I am just giving you the flavor of what is involved in both these topics, risk engineering and quality management. You should understand that we are speaking specifically in the context of bringing out a detailed design of a particular product that we are interested in. As I have mentioned in my previous lecture, design is very individualistic and creative, that it cannot be codified into some common practices. Therefore, what we are trying to do is try to appreciate certain issues which we should consider. In the last lecture, we discussed two issues, safety and reliability. Both are important issues. We want our product to be safe, we want it to be reliable. But how to make it reliable and how to make it safe in the design itself is the challenge. So today also the questions are same. There are two issues, risk and quality. We want to minimize the risk, we want to increase the quality. How is tough, but necessary, we understand. Let me first talk about risk engineering. Today, if you want to pursue your higher studies, you have an option of doing it exclusively in risk engineering. There are institutes which offer MS courses in risk engineering. It has become a full-fledged degree topic in itself. Why? Because risk, as all of you may understand, is a necessary evil. Not only in engineering, but in every walk of our life. What is risk? Om Shri Gurubhyo Namah 1000 times every day. Madam. What is risk? What is risk? We use it in everyday item. Risk. This is risky shot. What is risk? Potential danger. Meaning? Something may go wrong. May is the most important word there. Risk is always the probability of something which can go wrong. What you should immediately recall? What is that epigram called as? What is that epigram? If something can go wrong, it will. What is that? Correct. So, we know in life that if something can go wrong, it will. Therefore, we should take enough safeguards to see that that mistake won't happen, that wrong won't happen, that defect won't come in our product. Risk is the probability of failure. Here you should understand that something may go wrong is our assumption. But if you are damn sure that it will happen, that is, if the probability of some event happening is 100%, then it is not a risk, it is stupidity. Example, jumping from 10th floor or 100th floor. The person who is jumping cannot say, I am taking the risk. That's not risk, that's stupidity. Risk is jumping from second floor, maybe. I don't know. Not for me, but someone who is brave enough. That may be risk. May go wrong. But jumping from 15th floor definitely is not risk. What I am trying to tell you is, 100% sure risk is not a risk. It is either a limitation or a shortcoming, which you have to deal it in a different way. Somebody who is doing business, if he knows as definitely he will going to lose that kind of business proposition, he can't say, I am taking the risk. No, it's not risk. Risk is there is a probability of something going wrong which is in the range of something, say 50%, 60%. That is risk. So whenever we talk about risk, Madam is planning to jump from 7th floor. So she is in deep philosophical discussion with her friends. What, madam? You seem to be very busy. Coffee day? Wait till 4:30. Well, so the point I was trying to emphasize here is that 100% risk is not risk, but somewhere between 0% to 99%, not 90% also. Below that, if you are very sure that that event may happen, then you consider that as risk. That brings us to next question on how to identify the probability of an event happening. Or see, in any engineering design or generally in any activity we do, there will be many aspects which may go wrong. I am building the building. What are all the risks? Suddenly tsunami may come. There may be earthquake of, what is the highest? 7.9. Or suddenly US may tomorrow decide that enough is enough in Iraq and Afghanistan and Pak, now they will bomb Bangalore. What can you do? There are various risks, no? Anything may go wrong. What should we consider and what we should not consider is a question. Since there are many risks which are involved, how do you identify which to handle and which not to handle is the main question in risk engineering. There are various methods to do this. Ken Hurst describes the method called as Fmea, failure modes and effect analysis. Generally the concept is this, whether Fmea or any other technique. Concept is this. I am not going to elaborately speak on Fmea. In any risk engineering proposition, what you are doing is identifying all the risks. You just identify 1, 2, 3, 4, 5, 6. These are the issues which I consider as risks. Then you should rank them. You should rank them based on certain criteria. How to do the ranking is the main question. The process defined in Fmea is this. For every risk, identify 3 parameters. 1, rate of occurrence. Rate of occurrence. All the parameters you give marks from 1 to 10. Rate of occurrence. Do you think it is there is a high possibility of occurrence or low possibility of occurrence? Low possibility of occurrence, 1 mark. High possibility, 10 marks. Give the ranking. Probability of occurrence, 1 factor. Second factor, what will be the severity if that happens? What will be the severity? Effect, if that particular event happens. Again mark from 1 to 10. 1, less effect, 10, catastrophic effect, loss of life and other things. Second parameter. Third parameter is there a possibility of identifying and rectifying that particular risk? Again scale from 1 to 10. Easy to detect, 1, very hard to detect, 10. Using these 3 parameters, find the final scores of each issue and then rank the risks. Rank the risks. What all issues you find are under the category of maximum risk, you can consider them. Others you can safely forget. This is one of the ways of identifying and managing risk. See, Not all risks are avoidable. Though all of us like to avoid all kinds of risks, it is not possible to avoid everything. So what is the next best option? You have to manage the risks. See, for example, in human body also, none of us want any diseases. Many of the diseases are avoidable, but sometimes certain diseases we have to live with them. Sugar, there is no way we can avoid it, but once it comes, you have to know how to live with it. Pressure, I don't know. I'm not a student of medicine, nor do I have many diseases, so I don't know many things about that. The point is very simple. First, try to avoid all kinds of risks. If it is not possible, try to manage the risk. How to manage the risk? You have to have some kind of propositions in your design so that you can manage. For example, yesterday we saw such a design while we were speaking about reliability. We said that if there is a serial relation between components, the scope of the reliability of the system going down is enormous. Therefore, what do? You do a parallel kind of a design wherein one component coming down will not bring the entire system down. You have to come up with some idea like that. So such ideas have to be discussed to know how you can effectively manage the risk. Let me briefly tell you, I leave it to you to explore more, that in software design there is a particular model which is designed by a person called as Boehm. Boehm, B-O-E-H-M, Boehm. Boehm has given us what is very famously known as spiral model. Spiral model. That particular model discusses in detail on how to consider risk in software designing. If you are interested, you can see. If you can't understand that, you can come back and ask me, I will explain it. Boehm's spiral model is the way which is traditionally used in software engineering to deal with risk. You will learn more in your senior semesters. Let us leave it there. The main point here is only this, that risks are the probability of an event happening and causing the system to fail. 100% risk is not risk, it is a shortcoming. And you have to know how to handle risk. Risks are handled in two ways. Either you avoid risk or manage risk. To manage risks, there are certain design principles. To handle risk, you have to know how to rank the risks. How to rank the risk? Use three parameters: rate of occurrence, severity, and the ability to detect and correct them. Based on these 1 to 10 scales, you can rank the risks. This much if you know, it's sufficient. My next focus will be on quality. This is the last issue we will be discussing because of obvious reasons. There is a architect whom I like very much. His name is Christopher Alexander. Christopher Alexander has made one statement which I like very much. He says that buildings, he was speaking about buildings. He always makes a statement that buildings should have a quality without a name. Quality without a name is one of the famous theories proposed by Christopher Alexander. I feel that theory is applicable even to software. Whether a product is of quality or not, we have an intuitive feeling about that. It is not about whether it is performing up to a particular technical parameter or not. These are not questions at all. For example, consider a house. When you go into the house and see around, there is a certain aura, a feeling that you get. Architects usually say that their main job is to make a space, any empty space, a living space. They create living space, they say, that is their main objective. Not to make beams of a particular parameter and all these technical details. They are important. But more than that, that feeling which you get when you enter the house, that is most important. How to create that? How to create that quality without the name? We don't know. Quality, one more person has said, I can't remember the name, is like oxygen. You have it, you never recognize. But if it is not there, you can immediately recognize. Something about that is true about quality, I guess. You always feel that quality. But unfortunately, the world can't live with such philosophical things. They want some means and methods to determine the quality. Humans have done many things to try and standardize the concept of quality. Let me very briefly tell you about some attempts. ರಾತ್ರಿ ಎಲ್ಲ ನಮ್ಮ ಮನೇಲಿ ಚಿಕ್ಕ ಮಕ್ಕಳಿದ್ದಾರಾ? ರುಜೋಮ ನಿಂದು ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ ನಾನು. ಮನೇಲಿ ಚಿಕ್ಕ ಮಕ್ಕಳಿದ್ದಾರಾ? ಇಲ್ವಾ? ರಾತ್ರಿ ಎಲ್ಲ ಪಾಪ ತುಗಿ ಈಗ ಅವನು ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಕೆಲವು ಸಂಸಾರ ಕಷ್ಟ. Okay. There are many ideas on how to make quality products. In fact, Japanese people have proposed not one but 10 ways of promoting quality. They are obsessed with quality. I'll briefly touch on few issues, very briefly. One attempt done all over the world, accepted all over the world, is ISO. ISO is International Organization for Standardization. ಅದು ಬರೆಯುವಾಗ ಮಿಸ್ಟೇಕ್, ಪ್ರಿಂಟಿಂಗ್ ಮಿಸ್ಟೇಕ್ ಆಗೋಗ್ಬಿಟ್ಟು. It should have been iOS, but printing mistake ISO. It's actually International Organization for Standardization, ISO. A non-governmental organization which is headquartered in Geneva, which creates standards for both products and services. MSRT is ISO. We are ISO because we are in educational service. It says service ISO. Product ISO Allah. That means just because MSRT ISO, don't expect good quality desks, good quality food in canteen. They have not told that. ISO follows a golden principle. Say what you do what you say. That's all is ISO. Say what you do what you say is the principle in ISO. If you understand this line properly, you will understand what ISO is. What everybody does when they say they are following ISO is, ISO does not say that this particular standard, for example this fan, this should work for 3,500 hours. No, that's not ISO. They don't say anything. If you are the manufacturer of fans, you say that my fan will work for 10 hours. And if it works for 10 hours, that means it has ISO. That's all. Are you getting the point? Quality is sticking to your word. That's all. So if I say that in my canteen, I will give okay kind of food, which people may eat if they are very hungry, then we can get ISO, because you have said that. You haven't said that I will give top quality food prepared by the best of the chefs from all over the world. You haven't said that, no. With the cleanest of the environment. Where have you said that? So, ISO principle is very simple. You have to document whatever you say. For example, we say here in MSRT that we track students' attendance. How? We say there is a attendance. If you see here, it's there. It will be in your blue book also. According to the standards F704, that means we have defined the attendance register. This is how attendance register will be. And then teacher is supposed to come into the class and take attendance. We have never said they will give you quality lectures. We have never said that. What we have said is teacher will come in, he will take attendance. That's all we have said. You can read that document. It's available. Teacher will come, will stay inside the classroom for 50 minutes, 55 minutes, whatever is the duration. He may do monkey tricks here, he may teach, we are not bothered. He takes attendance, goes back, enters everything in the SIS, done. At the end of the month, collect the money, sleep. So, ISO has an advantage. Advantage is transparency. ISO assumes that customers will take an informed decision. Many people get carried away by the ISO mark. They feel ISO mark means it should have quality. It's not that. Any product or any service having ISO means that they are giving out the information. It is your responsibility to read the information and then take the decision. Unfortunately, that doesn't happen. This is one about ISO. We can go on speaking, but I am diluting. Please understand, I am diluting the core concepts and making you understand what they are. ISO, as I said, is applied both to product and service. Okay, these are different ideas. Second concept which has been developed, which is accepted worldwide, is Six Sigma. Six Sigma. You may have heard this. Six Sigma. What is Six Sigma? Six Sigma actually is a management concept for assuring quality. Six Sigma views quality as removing the defects. Six Sigma says that its main aim is to remove the number of defected pieces. For example, if your success rate is 99%, that is out of every 100 products that you make, one product is failure. From that range of reliability to 99.99% reliable. That is the aim of Six Sigma. How to do that? There is a various process model. There are people who are given designations such as black belt, green belt, white belt. There are people with assigned jobs. There is a process model which says what is the responsibility of the people who is having black belt. They should look at each step. That means they focus on removing the defects in manufacturing. How to improve the manufacturing process is the focus of Six Sigma. Unfortunately, that is the reason why Six Sigma cannot be directly applied into software. Though people try to equate between defects and bugs. They say that making software 99.99% bug free is Six Sigma in software. Unfortunately, it's not that simple. Not that simple. That is why in software we have a different view on quality. What is that? You may have seen. Companies advertise themselves. CMM. Company blah blah blah. A CMM level 5 company. You see the website or the advertisement, they will say very proudly. Just like product companies say they are ISO, please note the point that even software has ISO, but not many are worried about that. CMM, everybody is interested. What is CMM? CMM is capability maturity model. Capability maturity model. What is that in nutshell? In the nutshell, CMM defines what is called as KPAs, key process areas. There are 5 levels of CMM. Level 1 to level 5. Level 1 is lowest, level 5 is highest. In every level there are certain KPAs, key process areas. Any company which follows those KPAs at that level is supposed to be at that particular level. That's all. If you are following the practices at level 5, that means you can say everywhere that you are CMM level 5 company. It's a process. How to build software, the process is defined. You may be surprised that more than 90% of the software companies which have CMM level 5 are in India. Among them, 99% of them are in Bangalore. Why? I answer this in this way. MSRIT has ISO. IITs, they are not worried. They have their own brand name. Do you know any IIT or IIM which has an ISO? Do you even ask any IIT whether you have ISO? No. Similarly in software, Microsoft, IBM, Oracle, they don't have ISO or CMM. want to name, company 1, company 2, company 3, which are there in Bangalore and all, they all have CMM level 5, that this. Why? Because in a very competitive environment, when there is no other means to compete with each other, these certifications come handy. Ashtay, nenu illa. There is no other special reason. But what people have thought after some time in software is, see, in manufacturing it is very simple. You get good quality machines, you get good quality raw materials, and you follow the good process, you will get good product, correct? But how to make good software? There is no machine, there is no raw material. Who creates software? Humans create software. Therefore, after some point of time, people recognized that people are the most important resource in software. Therefore, in addition to CMM, we have one more idea called as PCMM. People Capability Maturity Model. Again, you see all this company 1, company 2 in Bangalore and in India in general, they all advertise. We are a PCMM level 5 company. Because if you and your competitor both have CMM level 5, how will you then differentiate? Then you say, I have CMM, PCMM level 5. He does not have. Atara. Then again everybody started having PCMM also. Now there is one more CMM. It's called as CMMI. Capability Maturity Model Integrated. Innu bekadre innu eradu ide. PSP and TSP. Personal software process and team software process quality models are there. What is the biggest thing about all this is, all this, that is CMM, PCMM, CMMI, TSP, PSP. All this is defined by only one guy. That person is called Watts Humphrey. I should find him. He has defined 5 process models. He is there in CMU, which is like the best place you can ever go to do your studies in software engineering. He is a professor there. 2 of our students from our branch are now students in CMU. In the SCI, it is Software Engineering Institutes in CMU. He solely has defined all these 5 process models. So how do we assure quality in software? You either go for PSP, TSP, that is personal software process and team software process, or you go for these 3 certifications: CMM, PCMM, CMMI. Fine? If you know this much, I think more than sufficient. So in a nutshell, in summary, we have completed the journey actually. The engineering design journey comes to an end here. What is remaining are fringe topics to be discussed. I want all of you to appreciate and understand one simple thing here. As I keep saying, we are not interested here to teach you everything. There is still 3 years left, you will know most of the details. What we want you to learn here is a very simple lesson, that in engineering, the emphasis is more on process, not on product, your end product. No. End product is necessary, but what is equally important is the way you do it, the process you follow. That is lesson number 1. Lesson number 2. All the decisions that you take in this process, you should be able to justify it, defend it. It should be an informed decision, because at every level, whenever you have to take a decision, you will have choice. How will you make the choice is the question. You should not end up like that guy. Yayati. Girish Karnad's play Yayati. Bad. Bit. There are 2 kinds of people, it seems. Whenever you are in crossroads, whenever you take left or right, there are 2 kinds of people. Yayati, Girish Karnad dialogue. One kind of people will choose one path, and afterwards they will not look at the other side. Those people will be happy. There will be other kind of people. They will choose one path, but constantly turn that side. What if I had taken that path? ನಿಮಗೂ ಫಸ್ಟ್ ಇಯರ್ಲಿ ಅನ್ಸ್ಬಿಟ್ಟಿರುತ್ತೆ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಇಂಜಿನಿಯರಿಂಗ್ ಮೆಡಿಸನ್ನು, ಆಮೇಲೆ ಇಂಜಿನಿಯರಿಂಗ್ MSRIT ಸಮ್ ಅದರ್ ಕಾಲೇಜ್, MSRIT, IS, CS, ವಾಟ್ ಎವರ್. ಯು ಹಿಯರ್ ಆ ಬ್ರಾಂಚಲ್ಲಿ ಎದ್ದೋ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರಂತೆ, ಇಲ್ಲಿ GPA won't cross 8.0, there see all my friends are scoring 9.9. In life as well as in engineering, whenever you have to take a decision, one, you have to take an informed decision, not take a decision by tossing a coin. You should take a judicious decision and as far as possible stick on to it. If you learn these two lessons, you will be more than happy. I hope you will do that. After we come back from internals, we will discuss the 3-4 fringe topics that we have to take.